Ever wondered how artificial intelligence makes its decisions? Artificial intelligence, or AI, is a complex and intricate system that often operates in ways that can leave even the most brilliant minds scratching their heads. It's not just a series of ones and zeros, but rather a convoluted network of algorithms and data that makes countless decisions in the blink of an eye. And sometimes, these decisions can seem as mysterious as the inner workings of the human brain. Even experts who have devoted their lives to understanding and developing AI systems sometimes find themselves stumped by the reasoning behind certain decisions made by these systems. This isn't just a fascinating puzzle for scientists to solve. It's a serious concern. If we can't understand how an AI system makes its decisions, how can we trust it? This lack of transparency can pose significant challenges, especially in high-stakes domains. Consider a scenario where AI is used in healthcare. Let's imagine a situation revolving around a patient named Jane. Jane was diagnosed with a rare form of cancer. Her treatment plan was devised by an AI system known for its precision and accuracy. However, the treatment plan was unconventional and her doctors were puzzled. They couldn't understand why the AI had chosen such a unique approach. This AI system was trained on millions of medical records and had learned from patterns too subtle for human detection. But here's the catch. It couldn't explain why it had made the decisions it did. It was like a brilliant doctor who couldn't communicate his thought process. Jane's doctors were left in the dark, unable to grasp the AI's rationale. The AI system's decision might have been the best course of action, but without an explanation, the doctors were hesitant to proceed. They were caught between trusting an opaque AI and risking Jane's life. The dilemma was real, and the stakes were high. This is not just a hypothetical scenario. AI systems are increasingly used in healthcare, and often they are black boxes, offering decisions without explanations. The lack of transparency can lead to mistrust, impede AI adoption, and even put lives at risk. The lack of explanation in this case raised ethical and practical concerns. It's clear that in spaces as critical as healthcare, we need AI that doesn't just make decisions, but also explains them. AI systems are also being used in the judicial system. Now, let's illuminate a real-world example where artificial intelligence was put to the test. A prominent case that comes to mind involves an AI system designed to predict recidivism rates, essentially the likelihood of a convicted criminal to reoffend. This AI, sleek and shiny, was welcomed with open arms, promising objectivity in a field often tainted by human biases. However, the honeymoon phase was short-lived. A controversy erupted when the AI system's predictions were found to be biased. The system was essentially perpetuating the very human biases it was meant to eliminate. The AI was accused of unfairly flagging people of color as high risk, while underestimating the likelihood of recidivism in white offenders. The fallout was massive, but the biggest issue was that no one could definitively explain how the AI arrived at its predictions. This was a black box of machine learning, where the inputs and outputs were known, but the process in between was a mystery. This case, which has now become a cautionary tale, highlighted the critical need for transparency in AI decision-making. Can we trust decisions we don't understand, especially when they hold such high stakes? The answer isn't simple, but it's clear that we need AI systems that are not just smart, but also explainable. This case underscores the importance of explainability in AI. We're reminded that as we navigate the brave new world of AI, transparency isn't just a luxury, it's a necessity. As these cases illustrate, the need for explainable AI is clear. Unveiling the inner workings of AI systems is crucial for several reasons. Firstly, transparency can help prevent misuse. If we can understand an AI's decision-making process, we can spot any potential biases or unethical practices. This transparency, in turn, breeds trust. For AI to be widely accepted, people need to know it's working in their best interest. They need to be assured that it's not a black box, making arbitrary decisions. Finally, explainable AI facilitates better decision-making. If we can understand why an AI system made a particular recommendation, we can make more informed judgments about whether to follow that recommendation or not. We can also better understand its limitations and areas for improvement. Therefore, creating AI systems that can explain their reasoning isn't just a nice-to-have, it's essential. Explainable AI is not just a luxury, but a necessity. However, creating explainable AI is easier said than done. The journey towards transparency in artificial intelligence is riddled with challenges and complexities. One of the most significant hurdles is the trade-off between accuracy and interpretability. In the world of machine learning, we often encounter models that are highly accurate but difficult to explain. These are known as black box models. They can make incredibly precise predictions, but their internal workings are largely impenetrable. On the other hand, models that are easy to understand, such as linear regressions or decision trees, may not always provide the level of accuracy required in certain contexts. This trade-off poses a significant challenge in creating AI that is not only effective but also explainable. In addition to this, the complexity of AI systems themselves is another obstacle. These systems can involve intricate algorithms and vast amounts of data, making them difficult to decipher. Moreover, the dynamic nature of AI, where models continually learn and adapt, adds another layer of complexity. Yet, despite these challenges, researchers are making headway in the realm of explainable AI. A promising development is the emergence of hybrid models. These models combine the accuracy of black box models with the interpretability of simpler models, aiming to provide the best of both worlds. Furthermore, new techniques are being developed to make black box models more interpretable. For instance, local interpretable model agnostic explanations, or LIME, is a method designed to explain the predictions of any machine learning classifier. It does this by approximating the black box model with a simpler interpretable model that is locally faithful to the original model's behavior. Another exciting development is the rise of counterfactual explanations, which explain the behavior of a model by illustrating what would need to change in the input data for the model's decision to alter. Despite the challenges, strides are being made in making AI more transparent and understandable. The journey towards explainable AI may be complex, but the destination is well worth the effort.